We're all taught to optimize. In engineering, in business, pretty much everywhere, it's the one instinct that always feels right, doesn't it? It always feels like we're making progress. But what if we're not? What if that relentless push to make things better is the very thing that makes our systems fragile and ultimately broken? I mean, from the moment we start learning, these words are just drilled into us. Faster, cheaper, smaller, more efficient. It's the mantra, right? It's the unquestioned direction of progress, the very definition of a job well done. And look, on a small scale, that totally works. Optimizing a single line of code or a single gear in a machine, go for it. But here's the twist. When you take that same thinking and apply it to the huge, complex systems that run our world, well, that positive force starts to look a lot more dangerous. It actually becomes a hidden source of fragility. So that's what this is all about. We're going to explore that breaking point, the exact moment where the simple logic of optimization just completely shatters. And we're going to make the case for a skill that's way more important than just squeezing out one more percentage point of efficiency: the wisdom of knowing when to stop. Okay, so here's how we'll break it down. First, we'll look at the optimization instinct itself. Then we'll ask the big question, progress toward what? After that, we'll find the cracks in perfection, see what happens when metrics lie, and wrap it all up with the wisdom of restraint. All right, let's start at the beginning. Why is this drive to optimize so incredibly powerful? Why does it feel so, fundamentally correct? Well, the appeal is really psychological. For one, optimization feels objective. You can put a number on it. Hey, we're 10% faster. Who's going to argue with that? It gives you this clean, measurable win you can literally chart on a graph. It rewards your cleverness, and maybe most importantly, it's exactly what most companies measure and reward you for. And this is really the heart of the seduction, isn't it? It creates this powerful, almost irresistible illusion of forward momentum. Every little tweak, every percentage point gained feels like a victory. It feels like you are undeniably making things better. But that feeling can be a huge trap. And that brings us to the single most important question you can ask when you're working on any complex system. When you say you're making progress, what's the actual destination? Are you even facing in the right direction? This leads us right into the core tension of this whole discussion. This constant battle between making one small part better and keeping the entire system healthy and resilient. This is the fundamental conflict. On one side, you've got what we call local Optima. This is the world where most of us live. Speeding up one database query, cutting memory usage, lowering the cost of one transaction. These are clear, focused problems. But on the other side is global health, the messy, complicated reality. Is this change going to break something for another team? Is it going to be a nightmare to maintain a year from now? What happens when something totally unexpected occurs? So here's the crucial point. Relentlessly chasing those local gains on the left very often comes at the direct expense of the global health on the right. Making one single part hyper-efficient can easily make the whole system brittle, complex, and fragile. So what does that damage actually look like in the real world? Let's talk about the hidden costs that come along with this pursuit of perfect efficiency. And this isn't just a theory. It shows up as really specific, predictable failures. You get those brilliant but fragile performance hacks that nobody else dares to touch. You get safety margins stripped away just to save a few pennies. Redundancy, the whole idea of a backup plan, gets labeled wasteful and is cut. The system becomes so specialized for one specific thing that it completely shatters at the first sign of change. And of course, everyone starts gaming the metrics. Now, to really understand this fragility, we need to define a critical concept that optimization basically sees as its mortal enemy: slack. Slack isn't waste. Slack is the buffer. It's the extra server capacity, the redundant data path, the unallocated time in a schedule, the mental space your team has to deal with an emergency. It is the very thing that allows a system to absorb shock and actually recover. And the difference is just stark. A system with slack can take a punch, a sudden traffic spike, a failed server. It bounces back because it has capacity in reserve. It can manage stress. But a system optimized to the absolute limit with zero slack, it's a glass cannon. The smallest problem cascades into a total meltdown. Recovery is a nightmare. And the people running it, well, they become just as brittle and overworked as the system itself. Okay, so this problem gets even worse when we realize that the very tools we use to measure improvement can actually lead us in the completely wrong direction. Let's talk about metrics. Let's walk through a classic example. Your goal is a noble one. make users happier. But you can't really measure happiness directly, right? So you pick a proxy, something you can measure, how much time users spend on your site. Then the optimization engine kicks in. The goal becomes maximize time on site at all costs. And what's the result? You might end up with a confusing, hard-to-navigate website that literally traps users, making them frustrated and angry. Your metric went up, but you achieved the exact opposite of your real goal. This phenomenon is so common, it actually has a name, Goodhart's Law. And the principle is simple, but it's profound. The moment you start optimizing for a metric, it loses its value as an honest signal. People will always find a way to make the number go up, even if it means destroying the actual goal. And you can see the fallout from this everywhere. Recommendation engines that chase engagement end up amplifying the most extreme and divisive content. Aggressive cost-cutting leads to critical infrastructure that just collapses under pressure. Systems tuned for the average user create a nightmare experience for everybody else. And over-automation strips out the one thing that can save you in a real crisis: human judgment.
So, if the relentless pursuit of perfection is the problem, what's the solution? Well, it requires a pretty fundamental shift in our mindset, away from perfection and toward robustness.
So what does a robust system actually look like? Well, its traits sound like absolute heresy to a pure optimizer. A robust system intentionally accepts some inefficiency. It deliberately preserves its safety margins. It chooses simplicity over complexity every single time. It will actively trade away some of its peak performance in exchange for long-term stability. And most importantly, it isn't just optimized for speed, it's optimized for recovery. The real question isn't how fast can we go, it's how fast can we get back up after we fall. And this might be the most important takeaway of all. Sure, in a perfect, predictable lab environment, optimization is king. But we don't operate in the lab. We operate in the real world, a world full of chaos, uncertainty, and constant surprise. And in the real world, robustness beats optimization every single time. This really forces us to redefine what great engineering is. It's not this mindless quest to squeeze every last drop of performance out of a system. The true art, the real wisdom, is in developing the judgment to know where that point of diminishing returns is, and then having the discipline to actually stop. Let's just end on this thought. Optimization is a powerful tool, no doubt about it. It allows us to achieve incredible things. But like any form of power, it's dangerous without judgment. The real goal isn't just to be powerful, it's to be wise. And in the world of complex systems, wisdom often looks a whole lot like restraint.